So today, I wanted to talk about how to do 3D milling, or how to create 3D milling toolpaths in Fusion 360. And for that, we'll need a 3D model. So I'm just going to download something from Thingiverse. Okay, so this looks more like it. So this looks really nice. This is something we could use. And yeah, in Think file, so we need STL file. So there are many ways. So in Fusion, you can build your 3D model like this structure yourself, or you can just import an STL file. And I have this mountain in the downloads folder over here. Yeah, it's downloaded. Like, look at that. It's really nice. And with the milling machine, we will try to mill as much detail as possible. And let's start with importing the model into Fusion. And let's start with a new project. I'm gonna save it as. Do I have a digital fabrication studio or something? I'll create a new project, digital fabrication studio. And save it as Mountain 3D Milling. Save. Close this panel over here, and then so we need to insert a mesh. So you go to insert mesh, and you have to choose the file from wherever you saved it. I'm also going to activate this mouse position application over here. Yeah. And as you see, we have a model, quite dense mesh over here. So while importing, we can also move it to the left or right if necessary. So we're just gonna leave it as it is. So here, unit type, millimeter, up direction. So you can specify all kinds of things while importing the model. What do we want to do? We want to inspect it a little bit. Let's measure. So let's select this corner over here and here. So the distance is 37 centimeters. So if we think, so it's around this. Somehow, if this is 25, then you add 10 centimeters. It's about this big. Another thing that we would like to know is how high it is. So let's set the top and bottom points. So the height, maybe it was not really straight. So let's put a point on the top of this mountain over here, and then try to match it on the bottom. And it's 25 centimeters high. Or we could also, just consider the milling area. But we could try to find some, so basically it also depends on the material that we have. First I'm going to show a basic way how to do this. So, from here we can choose also the material. We should choose the size of the material. So we have the model, and this model is going to be built out of like a certain amount of material. So we need some sort of cube that's going to be used in order to carve this out. Here for the bodies, we can actually hide this for a moment. And let's create a sketch on the XY plane like so. And let's draw a rectangle around this one, or yeah, try to kind of draw around it like so. Let's stop sketch. And now let's use the extrude method. So this one, create extrude, in order to extrude the sketch so it covers the mountain completely like this. So yeah, but basically this is one way to do it. We can also specify the material on when we are actually milling. So if we go a step back, so from here we can go to manufacture workspace. And as the first step, as you remember from when we were making the box, we need to create a setup. So we go to setup, new setup, and the stock part is important. So in our case, yeah, it's going to be a relative size box and around the model. So in order to have that, we need to go back to the setup tab and actually select the model. And this is going to be our model. And as you see, it's going to draw a box around the actual object and automatically give us the dimensions of it. So it's going to be 40 times 40 times 25. So we can, yeah. And just now, to be completely sure, I'll just check the material that we have when we have this big, because it would be nice also to be able to mill it. Because we have this foam, it would be nice to cut this out of foam. Just a second. But yeah, and taking into account that this is 10 centimeters, we could also shrink down our model. So if the model right now, if you see that this stock is, 25 millimeters, so some part of it is also the base. So this base structure over here. So let's go back to the model and measure how much is the base, and maybe we can remove it. There are many ways. So it's 20 millimeters. Basically, we need to. So yeah, it's if we subtract this 6 millimeters from the total height right now. So this 6 centimeters, I think. Or millimeters, it is. It is millimeters. All right, then.
It's like 3 millimeters. So then
that's actually
quite high, actually. So it can begin then.
Then it appears. Okay. It's actually very small. So it's if it's in millimeters. Oh, okay. Okay, so actually you can do it like so. There's a mesh workspace apparently, which is good. So right click. Edit. Okay, here we go. And we can select modify, and here we probably can modify, not physical material. No, I didn't want that. I want to go to modify and scale. So this, and scale factor, since it's millimeters. I'll hit OK for now, and I'll go to model workspace. I'll just draw a box for reference in order to be to understand how big I want it to be. So I will add a dimension here and here, and it's going to be 30 by 30 centimeters, but in this case it's 300 millimeters. And I'm going to somehow snap it to the center, I think. Construction line, I will add a point in the center of this one, and then I will snap that point to the center of the stage by using the coincident constraint. And I'm going to stop the sketch like so, and I'm going to extrude this by 10 centimeters like so. And now I can see what is going on here. What just happened? Sorry. Okay. And I want a free move, so I'm just gonna move it up so I can see. So basically, the size is fine. We could just mill the tip of the mountain, so over here somehow. Yeah, it's gonna be nice. So let's go to manufacturer workspace again. And for the setup, let's create a new setup. And for the stock material, let's select from solid. So let's select this box over here. And for the model, let's select this one. And then, yes, operation type milling, orientation, model orientation. So now we need to select X and Y axis. So let's select X axis first, and then Y axis. So we just select the edges of the model for that. But what we need to flip the Y axis. And we need to select the box origin, which is going to be the top of the material, which is this one here. It could be also the bottom, actually. So for 3D milling, it might be that the bottom, selecting the bottom corner is actually better. Let's do that this time. And for the model, we just need this one. So the 3D model, the mountain itself. And then hit OK. And usually this 3D milling happens in many passes. So usually there's like a roughing pass that removes the big amount, largest part of the material, and then there's a finishing pass. So 2 passes is, let's say, minimum. But you could also think in terms of different tools. So let's say that we do the roughing pass with an 8mm tool, and then we do the finishing passes with a 3mm tool or a 4mm. I would go with 8 and 4. So let's do that. In order to do that, you need to go and select pocket clearing, and you need to select the tool. Here's the tool library, so I'm going to go to my local library, and I'm going to select an 8mm flat tool over here. Another thing that we need to check is also what, in terms of tools, the length of the tool, because for 3D milling, it's kind of important to have a longer tool, especially if you're going deep into the material. So 10 centimeters is quite a lot. So for example, this ball end tool, you see it's quite long, so it could go maybe 10 centimeters into the material. So this could work, but it's a ball end. So for roughing, but maybe for cutting foam, it could be enough also with a ball end. So for example, this is an 8mm flat end, and but it's not that long really, so it's shorter. But we don't necessarily also need to go the full way, so we can survive with a bit less of the heights. So there's 12 millimeter ball end, so which is a really big tool. So basically, maybe we can just use these two. So since it's foam, it's like there's the flat end mills. It's better to use for harder materials. But then these ball ends, they look just fine. So let's do one pass with 12 millimeters and one pass with so this is 6 millimeter tool. Yeah, so for the 12 millimeter one, I haven't created a tool yet. So I'm just going to demonstrate you once more how to create a new tool. So go to new mill tool icon here. A dialog like this will open, and you'll need to specify basic parameters. So the type of the mill. So in our case, both of these are ball end mills, and we need to enter the number of flutes, material, high-speed steel, clockwise. So these are kind of the default settings. For coolant, we don't use any coolant there. And then the most important parameter here is the diameter, and you can do some additional measurements like the flute length, for example. So if I just make an approximate measurement, and then I see that it's 65, and then the shoulder length. I would say that it's 70, and body is let's say 75, and overall is 10. So you see the overall the overall height of the tool is 10 centimeters, which means that basically if we take 2 centimeters and it's into the holder, into the chuck of the milling machines, that means that we are left with 8 centimeters, and then still we should leave a space like 5 millimeters so it doesn't crash into the material. And that means that the depth of the cut that we can have in the material is actually 7.5 centimeters, so you have to be quite careful with that. And the shaft diameter is also 12, so it's like how big is this part which you put into the chuck. So yeah, take a closer look at this maybe. And yeah, the other options are you can give it a name, so it'll add a 12 millimeter, 2 flutes, ball and tool. Okay. And then yeah, I didn't finish editing it. I actually need to go back to the editor. Hit on edit. So this feeds and speeds part is important also. So we are going to use a spindle speed that is going to be 16,000 revolutions per minute, and we need to understand the chip load for this one. And I'm just going to reference the table that. Check the table that we have over here.
So it's basically a cheeseload file. Make it.
So, and for 12 millimeter tool, if we cut something soft, the feed rate can be from 0.64 to 0.69 millimeters. So it means that how much material it's going to cut off in one revolution. But since it's a ball end, I would go with something like, actually 0.7 should be fine for it. So I'm just gonna go with 0.7 over here. And it's going to give me a cutting feed rate over here, which is quite fast, 22,400 millimeters per minute. Like lead in could be easy, like 5,000 millimeters per minute for this type of material. Ramp feed rates, also 5,000, maybe 2,500. And plunge, this is how fast the tool moves downwards, also like 2,500 is okay. But then feed per revolution, I would go with 1/3 from the amount, which is going to be 0.2, like this, and then it's going to give me this
I think it's like the inner square.
surface speeds. This is like meters per minute. Okay. Yes, I want to override. Okay. And then here now in the pocket definition, so when the tool is selected, we can go to geometry. And so we want to select the model, which is this. Include setup model. Yeah. And for the heights, I will redefine the bottommost surface of this, so it doesn't. So if this is the material and this is the bottommost part, you know, this blue line over here, then we.
How do you change the filament to the matte line? It's not going in. I don't know.
Well, yeah, you can also try to do it at the nozzle level, so closer to the nozzle, so you can. Yeah, did you heat it up?
Yes.
Yeah. Well, the only way is just to try again. So yeah, and then we need to change this blue, the height of this blue line, so that we cut to a certain area. So basically, that we do not cut deeper than 7.5 centimeters. And so bottom height, it's not the model bottom, but we will go for stock bottom and offset it by. Actually, we won't cut more than 7 millimeters, and we offset it by 30 millimeters. So yeah, we won't cut deeper than 7 centimeters, meaning that if the stock height is 10 centimeters, so this is the thickness of the foam, and the tool length is 10 centimeters, but the usable part of it is going to be 7.5 maybe. So we don't want to cut more than. Then in 7 centimeters. So and with this offset we can control that, and then so for passes, I think like we can leave the default settings here. There's some stock to leave. So for the finishing pass, you can hit OK. Step over manually set for this cutter. So we need to set step over, which is how, so if you go line by line, so how close the lines are overlapping. So if the tool goes zigzag and is removing material, then we need to know how much it overlaps with the previous tool path. So, and manual step over.
Yeah,
Yes, it's the same. Okay. All right.
it should be the same.
Maximum step over, let's put it to 6 millimeters, and minimum, yeah, 1/10 of that, so it's fine. Let's hit OK. So let's try to simulate it and see what happens. I'm wondering, so if I will hide this body, and I can enable stock over here, so I can see where it's going to mill in. And yeah, I can hit play, and this is the way how it's going to cut. and speed it up. Yeah, so and here we have the mountain. Oh, yeah. And yeah, it's already quite smooth, as you can see. We can get it even smoother. So once we've done the roughing pass, we can actually do another one. So after the pocket clearing, we can go with some of these finishing passes, which can be different depending on the surface that we want to have at the end. So it really depends. I think these did you try these multiple times and then you understand which works best for you. So this morph spiral actually looks quite alright. And then, yeah, we again need to select the tool, and this time we are going to add the 6mm tool that I was talking about. Did I put it? Yeah, 6mm, 2 flutes. I think this is the one that I set up earlier. 2 flutes, 6mm overall length. Yeah, kind of the same settings as for the 12-1, but except the feeds and speeds. And the feed per teeth is kind of small here because I was using it for cutting really soft foam, and in order to cut it nicely, you need to go with really low chip load. Otherwise, it's going to rip it apart and twist around the spindle, and it's not going to look nice. So in our case here, we can go with 0.4 millimeters as the chip load, and for the spindle speed, let's go with 16,000. It's going to give us this feed rate, and lead in can be also 5,000. As for the 12mm tool, ramp feed rate is going to be 2,000. Here I'm going to select 0.1 maybe. Yeah, something like that, and hit OK. And for the geometry, you select the model. And for the heights, we are going to do the same as for the previous one. We're going to set the bottom to stock bottom and add these 30mm on top of that. Yeah, here. And then for the passes, step over is half of the tool. Right, and we are not going to leave any stock because it's the finishing pass. We're going to remove the remaining one. And now it's going to calculate. And now we can see both of those in context by hitting simulate. I'm going to hide the mesh over here in order to see the full experience. Now it's going to switch over to this other tool here, and these blue ones, these are the tool paths for the tool, and I'll play it back on with a smaller speed. I don't know.
Okay, so you just have to remember that. Yeah,
It was really quick, the last one.
It's practicing that way.
Somehow.
On the corner of the
yeah, I mean, it doesn't really matter. What we do it. Like,
It's so dense. Let's see, can I do it separately?
where are the holes? They marked there.
yeah, I marked it. I marked this. I marked the meters. No.
So maybe if I hide the stock over here. Yeah, you see it kind of goes only over these already existing surfaces here and just makes it smoother. So if you wouldn't have this adaptive clearing, so pocket clearing pass, then it will try to mill through this whole material, and it's not very good for the tool. So you see this is when it highlights, when the spindle is highlighting red, because Fusion tells you that this might be very dangerous for the tool, because it goes really deep into the material. So this is why you need these two passes.
But will it still show these lines? Like it is showing?
So these lines are the lines that where the tool is going to travel. So this is going to be translated into machine coordinates.
But will we see them?
Yeah,
Will
well,
it be-
that's like
or it will be as smooth as the mesh?
It's going to be it will depend on the tool. So let's just try to do this actually. So let's take into account that the Z origin is on the bottom of the machine, and then let's try to export this one by one. So we go to post process, and we select generic posts Mach 3 mil. So because we are going to cut it with our Recontech 1312 machine, millimeters. Hit OK. And I'm going to save it on the desktop with 3D milling Timo create. And I'm going to give it a descriptive name, so I'm gonna so it's like mountain, so like 30 cm mountain, 12